Welcome to Chapter 13. Chapter 13 is focused on Newton's theory of gravity. So we would like to understand the motion of satellites and planets. So here are the learning outcomes for Chapter 13. By the end of this chapter, you will be able to list the significant milestones in the history of gravitation. You will calculate the gravitational force between 2-point masses. You will estimate the gravitational force between collections of masses. You will explain the connection between constants or between the constants capital G and little g. Little g is the gravitational constant near the surface of the Earth. It's 9.8 approximately meters per second squared. Capital G will have different units and it's an actual constant, and we will understand what the connection between them is. You'll be able to determine the mass of an astronomical body from free fall acceleration at its surface, determine or describe how the value of g, little g, varies due to the location and Earth's rotation. So little g here, it should just say one of them. I need to correct this. Okay, it's okay. You will be able to describe changes in gravitational potential energy over great distances. So when we learned about gravitational potential energy, we simply said it's mgh near the surface of the Earth. But as you go away from the surface of the Earth, instead of just mgh, well, g itself, you're no longer near the surface of the Earth. So this is changing. It's becoming less and less than 9.8. So what is the gravitational potential energy then? We will learn about that. You will be able to apply conservation of energy to determine the escape velocity. You will be able to determine whether astronomical bodies are gravitationally bound. Okay? You will be able to describe the mechanism for circular orbits. In fact, that's the focus. They're really elliptical, but we will focus on circular orbits. Ellipses are harder to work with than circles, so we will focus on the circular motion. You will find the orbital periods and speeds of satellites going in circular motion, actually. You will determine whether objects are gravitationally bound. I think we talked about that a little earlier. You will describe the conic sections and how they relate to orbital motion. Conic sections really here, ellipses, maybe a hyperbola. But 99% we're going to talk about ellipses, and in fact mostly the special case of an ellipse, which is a circle. Okay. You will describe how orbital velocity is related to the conservation of angular momentum. You will determine the period of an elliptical orbit from its major axis.